Okay, good morning, good afternoon, good evening, whichever way or wherever you are watching this. So, I hope you're all enjoying a good break anyway. I think that's the first and foremost to say. It's nice to have a couple of weeks to just to sort of relax and breathe a little bit, just in terms of college stuff. So, it gives you that break. Then obviously the first week we're online, as I've said. So please just await an email that will come out. I won't do it today. It's Bank Holiday Monday, and you're probably thinking, why are you doing this on a Bank Holiday Monday? Is because, well, to be fair, it's a bit fresh outside, and I've been outside most of the time, so just taking a bit of time to do it. Plus, there are things work-wise sometimes, and you'll find this yourselves. There's bits sometimes you have to do when you're on holiday. It's just one of those things. So within your benefits, so that's all good. So the first week back, we are obviously going to be online, so I'll send the links out and the information. Then the week commencing the 19th of April, we're back in college, going on to the timetable that you've already had when we're coming in to just do practical, and that's going to stay the same. Okay, so I'll clearly identify it all in the email to you. Please, if you've got any questions about it, I'd rather you just ask me. It's not a problem, it's absolutely fine. Just ask me the question. But the first week back, we're on online learning, and that'll be on your normal timetable. So again, I'll give you the clues on those. Again, if you're not sure, just please shout up, it's not a problem. The other thing to mention is I know English and Maths have put out an update. If you haven't seen it, I'm not asking you to go and look at it because you're on holiday. But it would be worth you looking at it late in the week, maybe Friday, something like that, just to have a nosy. Their lessons are all back in college. So, obviously the first week we're online, you're going to now think, well, no, Mark's online and there's like a role reverse, what's going on? If you're late to some of my sessions or have to go early, I don't mind, okay? So if you just let me know, it's not a problem, okay? You know what we will be doing, preparing for exam A and preparing for exam B. It's pretty straightforward week, really, in terms of what we've got to do. But what I wanted to do today on this particular video is focus on Holistic Exam B. And there's two reasons really to why I'm doing it. The first one is I think it's the most difficult one you've got to do, and I've been quite upfront and honest with you, saying this one's going to be difficult, and you've all come back and said, yeah, they are quite difficult, aren't they? They are, and if we looked at it as a whole, as two groups, I'm going to talking to you as two groups. You've all done reasonably well, to be honest with you. Some of you have sort of kicked yourself slightly, and it's one of those things which is nice because you obviously care about what you're doing. But I think as a whole, two sets of group, you've done really well. So I'm quite pleased with what you've done. I know you might think, well, that's strange, we didn't all pass first go. Well, it'd be very strange, really, if you did pass all first go, wouldn't it, really? So it's just human nature, and it's one of those things, and it's fine. The beauty of it is, you know what you're up against now when you're going back in. So as long as you have your score sheets, and I've got one in front of me that I'm going to use in a minute, as long as you've got your score sheets, you should be able to pick out the areas for revision. And I think some of it is just, some of you have come out and said, oh, that question, whatever number it may be, I know the answer now, I've walked out, why did I do that? Well, it's just one of them things, isn't it? It's what the exams are like, unfortunately. The key thing is to make a note for yourself to say where you went wrong. If you do know you've made some silly mistakes, and that's fine, write them down so you don't make them again. And I think that's a bit of a learning curve just to go forward with. We all make mistakes, it's human nature, it's fine. So on Holistic Exam B, you've got cold, hot heating and sanitation. The exam pass rate is at 60%. So is exam A, which is science and site prep. That again is at 60%. And they're the two challenges, aren't they, that we face when we go back. We have the bathroom suites to finish, and we have 2 exams. Is it achievable? Absolutely, of course it is. And you'll be fine, okay? So you've got the 4 weeks to when you come back to do it. Yes, you're allowed more than one resit, as you know, because I'm going to be sending out some details for booking people back in shortly. So there we go, that's the idea. So what I want to do in this video, this apologies if this takes longer than what you may be expecting. I'll try and do this as reasonably well as I can. But I've got all the criteria here from Holistic Exam B, and I wanted to go through some of the different points from the criteria. Now, it's not me looking at it and go, oh, Mark's got the questions here. Mark doesn't have the questions. Mark never will have the questions because Mark, 1, doesn't want to know, and 2, it'd be wrong, wouldn't it? It's just the criteria. So I think it's useful if I go through some bits with you that just focuses you in terms of doing your revision and getting you sort of ready. Because there might be some bits that I say and you think, that makes sense a little bit more now. So I want to focus the video just really on these bits of criteria that I think you'll need to do. Obviously, if you've passed them, you can switch off right now, or unless you really want to watch it all, it's entirely up to you. So the first one is talking about your identifying types of hot water system layout diagrams. Right, so the easiest way to do this, let's have a think how you could do this. Now let's put you in the position of the examiner you're sitting there. The first thing it's an open book exam. You would therefore find where your hot water diagrams are and you put a label in there to say that's where they are. Now looking at it logically, the information I've given you, it should directly match the layouts that you see on screen. So it should be quite a straightforward one to do, including secondary returns and things like that. You should be able to find most of those straight away. So if it's a diagram, we should be able to match it, shouldn't we? And that seems to be the first sort of set of questions that come up, really. So having that in your mind that you're going to have to match some diagrams together is always a good idea. The next one is identify the need for temperature control of hot water systems. Well, this one we don't need a book for, I wouldn't have thought. So why do we need to control them? Well, one, risk is scalding, so we don't go to 65 degrees, which most, we know that, don't we, anyway? 65 degrees is where we are. We don't want it to scald us. In a bathroom, we can't have any more than 48 degrees C. That's under Part G of the water regs. Well, we know those two bits, don't we? And let's think of the third and foremost thing, that why it was taken to 65. Well, yes, you could argue heat loss, and I'll agree with that. But the fundamental principle of it is to stop Legionnaire's disease, isn't it? Because it will die within a period of time when it reaches 65 degrees C. And they're the points for that second point down that I've just mentioned. That might, ring a few bells for a few people and think, right, yes, I get it now. And it's stuff you know, and I know if I asked you it, you tell me the answer. I think it's just sometimes being in an exam and reading it on the screen, maybe. So there's another point there for you. Another one's backflow differential device are used in hot water systems dwellings supplying water to appliances. Well, you've got your check valves and your air gaps, haven't you? And that's always been the same in hot and cold water. Makes no real difference whether it's hot water or cold water. So you've still got those sort of key areas there to focus on. Identify types of typical size open vented cylinder used in hot water systems dwellings. Well, we've done a lot of stuff on cylinders, haven't we? We've done all the different types of cylinders, going from direct to indirect, to your single feed stuff, which is primatic, to a Vortex cylinder, to which is a combination unit, to an unvented cylinder, and we touched all those various ones that we've got there. So identify the typical types and sizes. Well, what's the typical type? The common denominator is an indirect cylinder, isn't it? Whether it's an unvented one, or it's a dual coil unvented or dual coil cylinder, which would incorporate a solar panel, possibly. But most of the time it's an indirect cylinder because of a coil, isn't it? And the coil gives off heat, but also separates hot water and heating. Whereas a jacketed heater, as we know, does the reverse. That's the whole idea. So what sizes of cylinders are we looking at as domestically? Well, it will vary on the property size. So there is nothing sort of set in stone that it will be this size. It can range from 120 litres between 120 and 180. So unless it's asked you a particular size, which I doubt it would, I'm not saying I would know that, but it possibly might not ask you the particular size. It might ask you which of these cylinders is the most common. It's just a thought from my point of view. So hopefully that gives you a little bit of guidance with that one as well. State how to fill your hot water pipe work with normal operating pressure and check for leakage. So these are this links into the next one, which talks about soundness tests and requirements. So we'll talk about those too, if that's okay, in one shoot, because I just think it's a lot easier. So what's the first thing you're going to do before you fill up? You're going to go around and do visual inspection. That's it, isn't it? That's the first job. You've done the pipe work, you're going to visually inspect it. Let's make sure I've soldered every joint, tightened everything up. Is everything going where it should be going to? Is it clipped sufficiently? Blah, blah, blah. The normal stuff. Then we're going to pressure test it. So 1.5 times the working pressure, usually for an hour. And that's what it's tend to do. There are variants to those tests, so that you do have a test A and you have a test B. They're all in BSEN 806. But on this particular exam and these standards, it's 1.5 times working pressure for 1 hour. And that's what you would look at doing, and that's basically, that covers those two areas there. Obviously, if you find a leak, then you repair the leak and you restart the test again from scratch, 1.5 times working pressure for an hour. You don't just sort of retest it quickly and say that's okay. So you have to restart the whole test from scratch. So hopefully again, that points you into the right directions. And with some of these things I'm saying, you can signpost these in your booklet where they are. Don't make it easy for yourself, that's the way to do it. Identify sources of information requiring undertaking work on a hot water system. Okay, so nice easy one this one is, where's your information when you're working on hot water systems? Well, manufacturer's instructions really is the answer, isn't it, to most things. Manufacturer instructions, if you don't have them, they're the British standards, and that's where you take information from. So if you were setting something up for the first time, you fitted something, now you want to commission it, where would you look at the information? Manufacturer instructions is where you're going to use it. With older appliances, just as an example, if you're trying to work out what the problem is with an older appliance and they don't have the manual in the house, you can download it. A lot of stuff you can download. So again, you can see why the MIs, which is manufacturer instructions, are so important. So identify preparatory work to be undertaken to build fabric in order to install decommission on water systems. Right, so this one is talking about your prep work to be undertaken when you're looking at the building fabric. So what is a building fabric? Maybe that's the first thing to describe, isn't it? What's the building fabric? Well, it's the brickwork, isn't it? It's the floors, it's the walls, it's so on and so forth. Now this could be all to do with, let's say we start with floors, for example. It could ask you about notching joists. That might be some, because that would be some prep work, wouldn't it? How do you remove a floorboard? How deep do you go to notch a joist? Well, we all know it's 1/8 of the depth of the joist. When you're marking out, if you're putting a speed fit through, we know it's no more than 3 diameters apart. And we know how to work out the mathematics again of those. So them two are quite simple. Chasing out in walls, it tells you 2 different key points in there of the thickness, how far to go into if you're chasing out into a wall, and how to mark out. So I would have really said for those 2 points there wouldn't be too much else. The only other thing would be fixing clips. So clipping distances, excuse me, 15mm you've got 1.2 and 1.8, and 28 you've got 1.8 and 2.4. That's horizontal and vertical when you look at them both that way. So that's really to the point where you're going to go. We know how to fix clips in. You know, if you're going to fix it with a red raw plug, it's a 5.5 drill bit, so on and so forth. So a couple of easy bits there. Again, I think you've just got to sit back and read what that's particularly asking. Okay, so now we're looking at how we're going to then take the readings of hot water supplies and flow rates. So, well, what do we do and how do we do it? Right, so we're taking readings of hot water supply and the flow rates. Well, we're going to do temperature checks. That's the first thing we're going to do, aren't we? Yeah, and we know we don't want to be above 48 degrees C. We know that, so that's easy. We check all the taps with a thermometer. We can check every one. That's nice and straightforward. Flow rates, what are we looking for? Well, in the manufacturing instructions, it will tell you what the flow rate from that particular cylinder or something would whatever be. You get yourself a flow cup, and then you open it obviously full in terms of the tap, and you take your reading across, and that'll tell you what your flow rate is. You're able then to compare the flow rate reading to what's in the manufacturer instructions, and you will make the decision whether it's right or wrong, and that's how you were going to do those. Identify how to make pipework connections to storage systems. Oh, the cold water storage systems. Crikey, we did some work on these, didn't we, with Bylaw 30 and Bylaw 31 with access points and spaces. Again, the obvious things to think about is that you'll see diagrams in your booklet of storage systems. Now, the first thing to mention is, before we go into any sort of measurements, and I don't necessarily think we need to, we just need to look at where it is in your book. Pipework has to have a natural flow, doesn't it? So if you've got your cistern and flow valves one side, the connection for the cylinder is going to be the opposite side, if that's the only connection, because we need a flow through of water, so we don't get any stagnating water. That would be one thing we need to think about. Remember when we looked at showers, we looked at those and we looked at a storage system being used for showers, weren't we? For a mixer shower, it was quite important that we spoke about what we did there. So the supply that runs off to feed the shower from that storage system, you know, the hot one was higher than the cold. So, for example, if the shower, there was a problem with it and the supply ran out, they'd end up having a cold shower instead of scalding themselves to death. So that's another picture you need to look at, and that to me would element and be into those areas of the storage system. Identify to use manufacturer instructions and job maintenance schedules to, and it says to, and it stops, to establish periods of service system components. Right, nice and easy then. So, job maintenance and maintenance records. Let's think about it logically. Where would you go and do maintenance work? Okay, it might be the odd job, but this is talking about scheduled maintenance. So scheduled maintenance is suggesting that it be in a school, college, office block, anywhere where there's lots of public. And when you have a scheduled maintenance taking place, it means it happens annually. It could be biannually or whatever it may be, but it'll certainly happen on a frequent occasion. So what you'll find with that is that we'll schedule. So for example, at the college, they'll be taking hot water temperatures periodically, and that's part of the scheduled maintenance. Why do I need manufacturing instructions? I think we've already answered it really, haven't we? For the simple reason is we need something to compare it to. I could go and take a reading of something, and if it doesn't match the manufacturer's data, okay, I'll have a good guess from the standards whether it's right or wrong. But if you think about it logically, you don't have anything to compare the data to. What's the point of taking the data? So that's what you need to be thinking of with those ones there. I will try and go through these fairly quick. It can be a bit tricky though, to be fair. Okay, to describe types of information provided on a maintenance record for hot water systems. Well, I've kind of covered it, haven't I? Flow rates and temperatures. That's kind of what you're going to record for hot water. There's nothing else to record unless there's been any work that's taken place. So if the system's been upgraded, yes, we might have to inspect it and do a visual inspection and make sure it complies. You would hope if that's the case it's already compliant anyway, but we'd have to go and do those checks in this flow rates and temperatures, isn't it? Okay, so state how to temporary decommission hot water system components and connecting pipework systems. So if we're going to do temporary decommission, well, that could be draining a cylinder down, that could just be switching isolation valves off. However we do it, we must make sure, one, there's some signage there to say do not switch water back on wherever we switched it off. So usually, you could say stop tap somewhere very, very similar. And it needs to be electrically safe as well, doesn't it? So those supplies need to be safe, and then we'd cap off any exposed pipe work as required, wouldn't we, to carry out that temporary decommissioning. Remember, the word temporary means you're taking some out of service for a while to be put back in. Permanently means it's cut off and that is it, no more, it's job done. So, if you think of you temporary taking something out, you're going to be capping things off, switching the supply off to it, aren't you? Draining the water down, put some notices to say not re-switch back on, etc. And that's what you would do. So hopefully, again, that one helps you at the same time as well. Okay, so this one's identifying methods used during decommissioning process prevent the end user and operation. Prevent the end user. I love this, end user, customer in normal language, from operating that water system. There's the signage. It's the signage and the verbal communication, isn't it? If you do those two things, what else can you do? There's not a lot else you can do, unless you're going to start taking heads off valves and things like that, which, okay, if you had to, you could. But that would be enough there. Okay, so that's the hot water section sort of covered there. And to me, if you've got your open book with those bits and bobs in there, it doesn't seem too daunting, hopefully. Hopefully I've said this stuff and you thought, oh yeah, it rings a bell, all this does. So again, make notes of those. The rainwater stuff I think is quite straightforward, but I'll go through it anyway because I don't want to miss anything, and I might even do this in 2 parts possibly. We'll see how long this goes for. So the next one is to do with your identifying working principles of gravity rainwater systems on dwellings. Well, what's the principle of it? Well, it's pretty straightforward, I would have thought, isn't it? It's to collect rainwater from your roof to discharge it away from the property and do it safely. And wherever possible to put the water back into the system to go back and be recycled. That's what guttering does, isn't it, really? It's nothing too more complex than that. Identify the factors which are used to determine the type size of guttering systems on dwellings. Well, we did a bit of roofing, which we spoke about effective roof area. Someone's mentioned effective roof area when I was chatting to them, and what does it even mean? Effective roof area is the roof measured in square metres. How big is the roof? Well, if the roof is rather large, the guttering will be equally as large, won't it, if that makes sense? I know it sounds very simplistic how I'm explaining this to you. What I don't want to do is go into massive detail on one of these videos because I'm going to speak to you all next week, so there's no real point in doing that. But obviously the bigger the roof, the bigger the gutter's got to be. It kind of makes sense, and the effective roof area is the size of roof that's working in square metres. Obviously you've got the pitch to take into account as well, and then we have to put it against a table in part H, and that will tell us what the gutter flow type is, size, various other things. Then we can look in the manufacturer's instructions, that's really bad, instructions, and we can work out exactly what we need sizes we need to put in. So there we go, hopefully that makes sense for you. State the purpose of components used in an eaves guttering system. So why are the eaves there? Well, it's partly the eaves are there, aren't they, to have your fascia board and your soffit board, which therefore gives enough overhang away from the building just below where your roof line is to catch your water. That's what it's there for. Eaves and gutters and things do need to be maintained because if they are from timber, they are going to rot at some point, sadly to say. So you're either going to be painting them or you're going to have them fitted as plastic. Identify source of information when carrying out work on gravity rainwater systems. So sources of information when you're working on them. I think the guess is whether it's a combined system, isn't it? Or a separated system, or a partially separated system. And they're the 3 you're going to want to know about, aren't they? And that's the bits you're interested in. Are you going to look at sizes? Well, you might do. 112 is usual for guttering, 68 for rainwater. They're your normal sizes. I can't really see there being too much other information there. State the position and fixing requirements of guttering system components. Well, it's a 1 in 600 full, we know that. Clips are spaced a metre apart. We know that. There's not really a lot else to say. Running outlets need to be positioned in such a point where the rainwater pipe can easily drop down to where the outlet is. So I don't think there's much more to say with that one, to be fair. Identify suitable methods for making new rainwater pipe connections to the drainage system. Well, this depends really on what you're going to go into, whether it's combined or partially combined or separated. So when it's talking about making new rainwater pipework connections to a drainage system, it might be talking you're connecting to existing stuff that's already there. So you'd use a type of fitting, like a proprietary fitting or something very similar, that will adapt from, for example, if you're dropping onto a bit of cast iron or something, you can get spigot sockets that do that, that clamp in. So again, depends on the question. That's a bit of a strange one to sort of almost comment on without really knowing the question. State the procedures for dealing with defects in gravity rainwater systems. Well, what the defects would be blockages. There's not really a lot else that can kind of go wrong with that, to be fair, if it's fitted correctly. So, it's wearing appropriate PPE and clearing out the blockages and retesting. State the test arrangements for gravity water systems to check the drainage. Well, that's obviously you're going to give it a water test, as you have done in the workshop, and as you would do if you just fitted some. You wouldn't fit it without, getting some water around, would you? You could either pour a bucket of water one end and watch it all go and make sure it does. The best one is to spray the roof, isn't it? And then, almost emulate the rainfall. That would be a good way of doing it. Okay, right, we're on to the cold water. Halfway. This one, state two main types of water supply to dwellings. Right, so water supply to dwellings, or does it mean the water supply in the dwellings? So you've obviously, with your water supply to the dwellings, you've got MGPM, you're buried between 750 and 1350. We know about those. They go through a sleeving, come up through the floor, 150 from the floor, stop, tap and drain valve. And the two systems you have aboard is a direct or an indirect, isn't it? So with that one again, it'd be usable if you just found those notes for those two. State how to fill cold water pipe work with water at normal operating pressure and check for leakage. Well, you're going to pressure test it 1.5 times working pressure for an hour. Same thing again, as we've said. This one is about soundness testing, etc. Well, it's the same as the hot water one we've just described. It's about doing a visual inspection, 1.5 times working pressure, 60 minutes. We check for leaks, we walk around, find a leak, we stop, we drain down, we restart. There we go, boom. Pretty straightforward, I believe. I'll make it sound obviously easier than what it is, because I don't see the questions, obviously, I don't want to either. Identify how to make joints to sanitary pipework systems. Right, so sanitary pipework systems, how do you make joints to them? Seems like I've skipped a page here, or have I? Let me just double check. I have. What a wally. There you go, look at that. We're not going to edit this out because I'm too far in. Never mind, nearly caught myself out. State the factors which affect the selection of cold water systems for dwellings. Well, what's the factors? Well, if we don't have good mains pressure water, there'd be no good having a direct supply, would there? Because we wouldn't benefit from it, because if we have low pressure coming in, that's it, that's all we've got. So if you have an indirect system, at least we've got a storage system that's filled with water, and we've got a bit better chance of having a better water flow, haven't we? So that's the factors that would take place, isn't it, to make you decide which one or the other. 2.4 then, or 5 even, because it does jump really around as well with some of their criteria. Identify the standard backflow device using cold water systems when it's water supply as well. Check valves. Job done, isn't it? It's a single or double check valves depending on the type that there is. Also, you've got air gaps, so very similar to hot water, no surprising what they're sort of asking for. Identify pipe materials and fittings required to complete work on cold water systems. So 3.4, sorry, I have to read these twice myself, it's mental. Identify the pipe materials and fittings required to complete work. Okay, so it's all got to be of a British standard, hasn't it? That's what it's got to be. It's got to be British standard, kite mark and RAS approved, isn't it? So as long as they're BSI kite marked or RAS approved, then there shouldn't really be an issue with the types of materials. There is a water fittings directory. It does tell you in there. It's like a very sad version of a phone book for plumbers, if you want to think of it that way. We can look in there and check a fitting to make sure it's suitable and compatible. Most of the time we don't have to because we know, but it is there should we want to. State the positioning requirements of components in cold water systems. Well, they're all laid out in 806, aren't they? So when you're saying state the positioning, the only logical things that jump to mind is your stop tap. It's got to be accessible. 150 minimum off the floor. We have a drain valve above it. We obviously want service valves at every single appliance, don't we? They're the logical components and sequence. We want some equipotential bonding on there into the cold water main intact. There's not a lot else really that would jump into play with that one that springs to my mind anyway. Okay, so the other ones is looking at identify suitable methods of making new pipe connections into existing cold water systems, pipework. This will be something to do with lead, I guess. So if there's a lead main supply, you can buy something called a proprietary fitting, and that will go onto it. It's called a lead lock in our terms, but that's the term is proprietary fitting. They love that word. It can mean anything, can't it? Actually, I'll just use this proprietary fitting, no problem at all. So that's what you're going to end up using there. There are some fittings that can go onto MDP and go to copper. So if you see a picture with one with sort of O-rings in, it's going to suggest it's going onto plastic. So look at those as well and just be careful with those. Okay, where are we? I'm losing myself now. Look, this is not good, is it? 7.1. So it jumps around. It goes to like 5, 6, 5, 7, and 7, 1, and it's very random. They've picked certain areas, I believe, anyway. Identify how to use manufacturers and job made schedules to establish periodic service requirements. Right, so cold water again, same sort of thing. You're checking temperatures of cold water, aren't you? Because if it starts to get a little warm, you run the risk of Legionnaire's disease again. You're going to go and check flow rates, aren't you, and pressures as well. So the same sort of things we've described in hot water is what you're going to look at there. So that's nice and easy. Identify the types of information provided on a maintenance schedule. Just covered it really, haven't I? Yeah, flow rates, temperatures, pressure. State the information these provide to other persons before decommissioning takes place. Well, the nice, easy, obvious one is if we're switching water off, we need to let people know, don't we? The terraced house situation that I've said to you on many occasions now, you know, if you're switching one off in the middle of a terrace, you might be switching 3 or 4 off either side. So it's going to have that communication, isn't it? Like saying I'm switching the water off. You know, it's going to be off for this amount of time, because we should be able to work out how long it's going to be off, and then whenever's possible, getting it capped off and then reconnected back on. You know, you can work around supplies like depending on what you're doing. So you want to switch it on as soon as you can, don't you? That's the idea. Identify methods used during decommissioning process to prevent the end user from operating the cold water components. So again, it's the simple signage near the stop tap or wherever you switched off, capping anything off that you need to in the verbal communication. So to me, that one's quite straightforward. Might be the way the question's worded, don't know, but we've had a few different scores on a few of those. Heating, we're getting there. No, it's not. I'm talking rubbish. Sanitation. And he said something else, which we've actually gone quite well with sanitation. Identify different types of sanitary appliances used in dwellings. Well, that's easy, isn't it? That's got to be straightforward, isn't it? Really. So bath, toilet, basin. So you got bath, toilet, basin. You got a shower cubicle, you know, shower tray if you got one, and a bidet at the very most, and that's about it, isn't it? So I can't really see them being too much of a challenge there to work out what's in the bathroom. Next one is identify how to carry an air test of pipework consistent requirements. Well, somebody spoke to me about this, and I do remember this because I made a few notes myself as people came back. So it's 38 millibar for a 3-minute test, and we should have 0 drop. Now I believe in your questions, from what somebody's told me, it says it in millimetres. So sadly it's 38 mil, which is not right. It's in millibar because it's using a manometer. So that's what it would be: 38 millibar, 3 minutes, 0 drop. Job done. State the system layout features for branch discharge. So that one again, I would use your diagrams for. You know, I'm going to speak to you all again next week, and we're going to do the revision about it. But that's what you'd need to look at there. State system layout features stacked ventilation, dry portion of the stack. Well, that's easy. That's the bit that goes above the top, isn't it? So that's the old 0.9 if within 3 metres, and the birdcage on top. If it's internal, it's a Durgo, isn't it? 1 metre above the highest spillover level, which is a basin 800 from the floor. So that one is quite easy. I say it's easy. I make it sound easier. I don't know perhaps what maybe the question is. Identify sources of information required when carrying out work on sanitary appliances and pipe work. So I've got to reread it because it's on 2 pages. So the type of sources of information required when working on sanitary appliances and pipe work. What's the type of information needed? It's a tricky one, isn't it? What sort of information would you need if you work on sanitary appliance and pipe work? You'd need to know your pipe sizes, but you'd visually see a lot of that, wouldn't you, as well? Heights and positions of appliances, possibly be one for a bath and a basin. A bit of a strange one, that is. It's hard for me to mention too much with that one. Identify how to make joints to sanitary pipework systems, where you've got push fit, solvent weld or compression. There's Volcathene and things like that, but you could class that as compression if you wanted to. Say how to select brackets appropriately such as recommended spacings. So yeah, it's a 0.5 and 0.8, isn't it, for that one? But please just check the table. You've got a table in your booklet, and it should show you what that is. So you just have to look at the booklet for that one if you can't remember it. How to use manufacturer's job maker schedules to respond to some of the systems. Right, so there's a few repeating ones here. So manufacturer instructions, we know it tells us what to do, how to fit it, what to do when it goes wrong, all those kind of things. And periodic servicing is the checking, which would be trap seal depth checking, wouldn't it? Which is you put your black dipstick in and measure the depth of the trap seal after performance testing. So that has to be part of it, I believe. Working methods to reduce periods of joy when the toilets wash facilities are not available to the building users. This one's a quite a straightforward one, and most of you guys say this person's, I mean, got 100% on a lot of things on here. So in terms of that, you would do it out of hours then, wouldn't you? That would be the logic, wouldn't it? So if you can't leave people without toilets and washing facilities, you could provide temporary ones, I guess, which you could do, like portaloos and things. But really, if it's going to be shutting off for a whole building, then you'd do the work at night so it wasn't disturbing for the people in the day. That would make sense to me. Safety procedures for handling sanitary appliances and pipework contaminate foul waste. Well, that's quite straightforward with large waterproof gloves, isn't it? That's quite a simple one, really. Right, heating, we're getting there. 300 hours later. So, state the purpose of a central heating system in dwellings. Well, this person, I'm not saying who it is, they got 0, come on. Why do you have a heating system in your house? It's for thermal comfort, isn't it? There's no other logical explanation. Now, I'm not being offensive to that person. That question could be totally different from what I've just read, but the criteria just says state the purpose of central heating system in dwelling. That's the purpose, it's for thermal comfort, isn't it? There we go. Next one is identify how to carry out sound tests according to heating systems. 1.5 times working pressure, 60 minutes. You get the same old stuff, the same sort of thing going on. Identify types of heating systems from layout diagrams. Apologies if you can hear some random person reversing. That's essentially a system from diagrams. Look at your diagrams. So you've got one pipe, you've got two pipe, haven't you, in there? You've got Y plan, you've got S plan, you've got Air plan, S plan plus, you've got C plan, you've got W plan. You've got a microbore system on there. You've got pressurized systems. Just have a look for the diagram and match, with how many motorized valves there are. Is it 3-port? Is it mid position? Is it not mid position? You can work that out. I'm sure if you spent time looking at it, you'd work it out. So state the general operating principles of gas-fired heat producing appliances. Well, this one's the weird one. Someone came back to me with this, and I'm going to mention it on here because it might be useful. Now, it might be completely unuseful to you. I don't know. But a general operating principles of gas heat fire producers. So it's asking you basically the basics of a boiler. Now, we did a session on boilers some while ago, obviously. So what's the principles of a boiler? Well, gas is going to come into the gas chamber, the burner is going to ignite. I'm doing this simplistically, so it's not because I don't think you'll understand. I'm trying to keep it simple so it's easy and quick to get. As the gas is burnt, the gas goes out something called a flue. The flue is going to stick outside your wall in a good position where it's not too near windows, etc, etc. And basically what it does, all the gas that's burned, we call products of combustion, which it is, and that's pushed out to atmosphere from a flue. And I think the question was relating to the flue. So that's F-L-U-E, not flue as in like, oh God, I feel really bad. That kind of flue. So I do remember someone mentioning that to me, so I thought I'd drop that straight in there. Now that could be completely wrong. Not what I've told you is wrong, but that question could be completely different from what I've just described, and that's the trick to it. State the operating principles of central heating system components. Well, if you look at what the components do, you've got TRVs, haven't you, which measure your air temperature on there. You've got automatic bypasses that regulate the amount of flow once everything switches off on there as well. There's loads of different control systems, isn't there? You've got something called a boiler interlock, which is room stats, it's cylinder stats, it's boiler stats, it's TRVs, it's all of those things that's under what you call the CHESS specification, which is the Central Heating Efficiency System specification. They didn't actually say that, I didn't do that properly. But look at those pages because all the control systems are there for you with the controls. Have a look in your own house as well. Does help a little bit sometimes if you have a nosy around. But don't play with anything, obviously. Identify the sources of information required when taking work on central heating, manufacturing instructions, what am I working on, etc, etc. Prep work required. Again, there's a theme here, isn't there? There's a theme building up with this, and I see what the theme is very clearly when I saw some of your sheets. Notchings of joists, drilling holes through joists, prep work in terms of walls, hanging radiators, minimum 150 off the floor, all those things as well we need to look at. Okay, so again, have a look at those. Position and fixing of various heating pipework components, what I just mentioned, radiators, so that's quite simple with that one. Position and fixing of components within a heating system, so you're looking at the diagram, where would they be installed, so TRVs for radiators, auto bypass, a lot of them inside a boiler. You can have them external to the boiler, obviously. Pressure vessels and various things can be external to the boiler as well as being internal, so it depends on what you're looking at. Fix, connect new heating pipework to components, so it's normal 15-22mm, isn't it? Identify manufacturer instruction, job main schedule, provide servicing requirements. Well, servicing is back in the back of a manufacturer instruction booklet where everyone has their heating system serviced and all the checks that you'd make with those. Safe procedures for dealing with defects in central heating components and requirements. So how do you deal with defects? Well, worst case is you remove something to put something else back in, like a pump, etc., and retest, don't you? Identify work sequences for permanent decommission of heating and pipe work. If we're permanently decommissioning, we're taking it out, aren't we? We are removing everything, so from a source of water to the electrical supply has to be permanently decommissioned and made safe. And identify methods used during decommissioning process to prevent entry use in the system. And again, that's locking everything off in position, isn't it? So no one can tamper and use it. And that's the idea. So there's a bit of a theme there throughout that particular exam. I'm glad I'm at the end of that one. Please let me know if that's of use, what I've just gone through and done. I've looked at the criteria and I've just gone through what my point of view is for each one of those bits of criteria. That's what's mentioned in your exams. Hopefully for some of you, you might go through this video I'm taking it and think, right, I can see what the point of it is now. Key is as well, if the things you're not sure about when you come out from these exams, come and talk to me. But please don't ask me as if I know what you've sat or what the questions are, because none of us know in the country what you've sat, and we don't want to, neither do we need to. But if there's something you're not sure about, if you come and sort of give me half a question and say, well, what's your answer? I say, I don't know, because I don't know what the question is. So it's very hard for me to answer a question if I don't know what it is. It's the same as anybody else. So that's hopefully some use for Holistic Exam B. Okay, look out for Holistic Exam A. That one will be coming out shortly. We'll be to a couple of sort of week or so sort of time, because I just want to go through a few bits with those. Hope you're all enjoying a nice break, and what the weather we do have has been quite reasonable so far, hasn't it? Not seen any snow today, thank goodness. But there we go. So anyway, take care of yourselves, and I look forward to speaking to you all on the sort of first week after our Easter break online. Take care.